All right, in Unit 7, we're going to be talking about special quadrilaterals and proofs. In number 49 here, Carla is thinking about parallelograms and is wondering if there are as many special properties for parallelograms as there are for triangles. She remembers that it is possible to create a shape that looks like a parallelogram by rotating a triangle around the midpoint of one of its sides. So what I'd like you to do is draw in a midpoint to one of the sides here. The midpoint is going to be like the point right in the center of that line. And then let's go ahead and trace. I'm going to do it a different color so you can see it rotate. So I'm going to trace the existing triangle that we've got here. If you are using a hard copy of the notes, I will have the patty paper on the teacher's desk, and you can come up and grab that if you would like to use the patty paper to trace on the hard copy paper. Okay, so once you have that traced, what we can do is we can use our scissor tool up at the top. We can rotate that triangle around the midpoint of that side. And so then it should look like this about. Maybe we can make that better. All right. And so after you rotate it, we're on part B now. Is Carla's shape truly a parallelogram? Use the angles to convince your team that the opposite sides must be parallel. So we need to write a convincing argument that the lines are parallel. Now here's the thing. We need to be a little bit more specific than what we were on our test last unit. So you have to pretend like you're a lawyer and you're arguing this in court and that your argument has no holes in it. So you want to be very specific about which angles and sides that you are talking about, but then you also have to give a reason for why you know something has happened. So I'm going to use my pink highlighter here, and first let's work on proving that these pink lines are parallel. So if we use this line as the transversal, we can say that, oh, you know what, I'm going to give each of these letters so that it's easier to talk about. So we can say the measure of angle A and C, see how they have the same tick marks? We can say the measure of angle BAC, angle BAC is congruent to angle DCA. And how do we, so since these angles are congruent, then we can say that lines AB is parallel to line DC. And then we can say because we know if alternate interior angles are congruent, then the lines are parallel. Okay, so here we are being very specific about what we know to be true, and then here we are giving a reason for how we know those specific things are happening. And now we can continue that to prove that the other lines are parallel. But before I do that, I'm going to put in little arrow tick marks to show that I've proven this. And now what we want to do is we want to prove that the other pair of lines are parallel. So now we have to prove that AD and BC are parallel. We can use AC as our transversal. And now we can say something similar, but this time our alternate interior angles are different. The first alternate interior angle for these green lines would be angle DAC and angle BCA. So we can actually say the same thing. It might be, if you've got the Notability, you can probably just copy that statement and paste it, but we're just going to change a few things here because we're proving different lines parallel because of different angles. So I'm going to erase my angles here. And then the lines that I'm proving to be parallel. And so now I can change that to say, okay, since angle DAC is congruent to angle BCA, then lines DA has to be parallel to lines BC. Because if alternate interior angles are congruent, then the lines are parallel. And part C, what else can the congruent triangles tell you about the parallelogram? Look for any relationships you can between the angles and the sides of the parallelogram. So we want to find out what else is true other than the two lines are parallel, the two pairs of lines are parallel to each other. So there's my two arrows to show that those sides are parallel. And so what else can we prove based on the fact that we know that this triangle is a rotation of itself? Go ahead and take 2 minutes, pause the video, and write in your own notes other things that may be, other characteristics that may be true for this parallelogram. And then when you've given it a shot, you can go ahead and unpause and I will give you the solutions. All right, so what else we do know is because this is a rotation, we can say that segment AD is congruent to segment BC. And then we can also say that AB is congruent to DC because it's a not a reflection, it's a rotation of itself. So those corresponding angles have to be congruent because when we did the rotation, the sides didn't change. So we can conclude that opposite sides in a parallelogram are congruent. And we can also prove or show that opposite angles are congruent. Take a look here. We've got angle D and angle B here. They have the same tick mark, so they're going to be congruent. And then also if you take a look over here, angle DAB and angle DBC, they're congruent too because you're adding congruent angles together, then those should be congruent as well. All right. If you need to pause and rewind, don't be afraid to do that while you are filling out your notes. I'm going to go ahead and I'm going to skip part D because we're basically going to do it in number 50 below. So we can cross that off. We're going to use the same figure below in 50, but what we're going to do in this time is we're going to get a little bit more detailed than we were last unit with creating our flowcharts. So the first thing that we want to do when we're creating our flowcharts is we want to start with the given information. So the given information in this picture, one piece of given information, is the fact that AB is parallel to DC. So those arrows mean the lines are parallel. Arrows do not mean congruent, they mean parallel. So I'm going to start off by filling in one of these bubbles and saying that segment AB is parallel to segment DC. And so underneath each bubble, we are going to give a reason. Before we just gave a reason at that very last bubble here, but what we're going to do is we're going to give a reason for each one of these now. We're going to be more specific so that there's no holes in our argument for why we're proving something is true. So how do I know that these lines are parallel? Because it was given to me in the picture. So that's what we're going to write right underneath the bubble, is that that information was given. Now, if those two green lines are parallel, what can we conclude? So we can conclude that angle ABD is going to be congruent to angle CDB because if the lines are parallel, then alternate interior angles are congruent. So in the next bubble, I'm going to write down the specific piece of information that I was able to conclude given the parallel lines. I can conclude that the specific angles ABD is congruent to angle CDB. And then how do I know that? I know that because if, and we can write that in here, if lines are parallel, those two straight lines mean parallel. If lines are parallel, then our alternate interior angles are congruent. And I'm going to use the symbol for congruent. Okay. Now let's go to our next given. I'm going to go ahead and erase those green lines. Another thing that we are given is that line AD is parallel to BC because we're given those arrows. And so what we can do in that second bubble from the top is we can say, okay, the other given information is that segment AD is parallel to segment BC. And how do I know that? Because the arrows are given to me in the diagram. So I can just say the fact that they're parallel is given. Now, if we use DB, that shared side is your transversal, remember your alternate interior angles are kind of like in the little angles, those little elbows of your Z or your N. And so now we can say angle ADB is congruent to angle CBD. So because the lines are parallel, I can conclude that angle I can prove that angle ADB is congruent to angle CBD. And how do I know that? Because if the lines are parallel, then alternate interior angles are congruent. So you can either recopy this word by word, or you can do like a copy paste here because they have the same reason. We know that because if lines are parallel, then alternate interior angles are congruent. So we're giving a reason after every bubble. Now, we've used all of the given information, so I'm going to erase those blue lines here. But what we need to do is we need to come up with something else that we know. Because in order to prove that these triangles are congruent to each other, there are 5 different ways that we talked about. You can prove triangles congruent with side, 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 angle, side, angle, side, angle, 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 side, and then the HL postulate. So we're trying to use one of these to prove that those triangles are congruent. But we only have 2 pieces of information. We have an angle and an angle. We've got 2 angles down here that are congruent to each other, but we need one more piece of information. So if we look at our figure here, what else do you know just from looking at it? Go ahead and take a couple seconds to think about it. Okay, so what we can conclude is that the DB is congruent to itself because it's that shared side. So because it's not given and I had to give it and I had to think of that on my own, what I did was I'm going to put it in this bubble that's in line with the things that I figured out because of the given. So I'm going to say DB is congruent to DB. And how do I know that? Because it's a shared side. What you could also say is the reflexive property. If we're getting into technical terms, if you want to use the technical term for shared side, it's called reflexive property. You don't have to put both of these. You can just say shared side on the quiz or the test, and that would be fine. But I do want to introduce you to the reflexive property. That basically means the same thing. It's a shared side, so it should be congruent to itself. Now we have enough information. Now I've got, now I've got an angle, a side, and then an angle. An angle, a side, and then an angle. So angle, side, angle is going to be the reason that we know that these are congruent. And so we would write that down here, angle, side, angle. And then what are we proving? We're proving that triangle ABD is congruent to triangle. Why don't you pause the video and try to finish that congruency statement on your own. All right, now that you've tried it on your own, I'm going to tell you that the A corresponds to the C. The B would correspond in the D of the bottom triangle, and the D in the top triangle would correspond to the B in the bottom. So the D and the B need to be switched here. So this would be how you would write the correct congruency statement, and then here is how you're going to do a flow chart from now on. You're going to be a little bit more specific about why you know something's happening, and then you're going to start with the givens. In 51, Kip is confused. He put two triangles from problem 49 together as shown below, but he did not get a parallelogram. What shape did Kip make? I would like you to pause this video while you try part A, B, and C on your own or with your group is fine. And then when you are done answering A, B, and C, you can go ahead and replay the video to see what I have for my answers. All right, what shape did Kip make? He made a kite, and then justify your conclusion. So I know that this is a kite because we have got one pair of congruent sides, and then we've got another pair of congruent sides. And so what's special about a kite is that you've got two pairs of congruent sides. Two pairs of congruent, I'm going to say consecutive sides. Consecutive means right next to each other. Okay. And then part B, what transformation did Kip use to form a shape? Some of you might have said a flip. Others may have used the more technical term reflection, but a reflection is a flip of that figure over that line of symmetry. What do the congruent triangles tell you about the angles of the shape? So one thing that I would like to point out is that you've got one pair of opposite angles congruent. Which would be like this angle and then this angle. And then what I would also like to highlight is the fact that this line of symmetry is cutting those two angles in half, also known as bisecting it. So it's cutting, it's cutting that big angle in half so that both of the two smaller angles are equal. And then it does the same thing down here. I should probably use a different color because they're not equal to each other. So we would say that the line of symmetry bisects, which is fancy for cut into two congruent. Line of symmetry bisects opposite angles. Right. We did not have time for 52 in periods 5 and 6, so don't worry about doing that. If you've gotten this far, what I would like you to now do is there is a new cheat sheet. It is a green cardstock now, so green card. So I want you to fill the green card with everything that you know about parallelograms and kites that we talked about today. So this is going to be your new updated cheat sheet with all of the information that you know about your quadrilaterals, specifically today the parallelograms and the kites. I do want to tell you that I want you to expect to have a quiz on Thursday. It will be open notes. So make sure that you are taking the best notes you've ever taken so that you can do well in this quiz we've got on Thursday. I'm sorry I couldn't be here today. I should be back tomorrow though. Have a good one. Bye. If you haven't already, start your homework if you've got extra time in class. That way you don't have much to do tonight.